What does it really mean for an AI to think? Today, we're diving deep into Interview.net, application security. Application layer attacks cause 40% of breaches. .NET runs 25% of enterprise workloads. API attacks surge 300%. The supply chain threats expand. Security must be embedded in the runtime and development workflow. Defense stack, transport security, authentication middleware, policy-based authorization, data protection API, integrated DevSecOps pipeline. Zero trust and compliance require intrinsic defenses, not perimeter scans. Traditional pen testing post-deployment is too slow. Vulnerabilities become technical debt. The session covers secure architecture patterns, DevSecOps integration, and compliance automation for .NET ecosystems. But here's where it gets interesting. The attack surface no longer has a perimeter. Microservices architecture decomposes monoliths, increasing API endpoints 10x. Each endpoint is a potential attack vector. Authentication spans boundaries. API-first design exposes business logic directly to clients. NuGet package ecosystem, 1.5M packages, any can carry malicious code. Cloud-native deployments, containers, Kubernetes, multi-region. Traditional network firewalls cannot inspect application logic. Result: application layer is the new battlefield. Attackers exploit business logic flaws, not just network vulnerabilities. OData, GraphQL, gRPC modern protocols expand attack vectors. Bots target APIs continuously. Serverless functions, event-driven architectures further dissolve traditional boundaries. So what's the real problem? Let's talk about why .NET applications remain vulnerable. OWASP Top 10 2021, still prevalent injection, broken auth, sensitive data exposure, XXE misconfig. Many .NET developers overlook built-in security features like anti-forgery tokens, request validation. Time-to-market pressure prioritizes features over security reviews. Threat modeling rarely practiced. Only 35% of teams perform it. Default configurations often allow overly permissive CRS. Debug endpoints in production. Result: predictable exploits in every sprint. Security training gaps. Developers not equipped to recognize injection or deserialization risks. Insecure deserialization, BinaryFormatter, JSON.NET miscopy, OpenRCE. This raises a critical question: the cost of insecure .NET. 67% of .NET apps have at least one critical OWASP Top 10 flaw varicode data. Mean time to remediate a critical vulnerability: 68 days. Average cost of a data breach in 2025, $4.45 million IBM. Only 30% of identified vulnerabilities are retested. Security debt accumulates. Each sprint adds new weaknesses. Compliance, GDPR, HIPAA fines compound the risk. Penetration testing finds issues post-release. Fixing then costs 30x more than in development. Cyber insurance premiums rise 50% for organizations with poor application security posture. Now let's zoom in on bolt-on security is broken. Post-deployment WEFs and pen tests detect symptoms, not root causes. Code reviews without security context miss logic flaws. Security teams act as gatekeepers, not enablers. Developer friction slows releases. Scanning tools produce false positives, causing alert fatigue. Manual compliance checks are inconsistent and unscalable. Result: the same vulnerabilities reappear. Mean time to fix remains high. A paradigm shift is required. Security embedded in the developer inner loop. Security must become an integral part of the CI/CD pipeline with automated guardrails. Here's something most people overlook: the shift left, framework integrated defenses. .NET provides security primitives built into the runtime, not add-ons. ASP.NET Core Middleware Pipeline, a programmable security gateway. type safety, memory safety, code access security, reduce entire classes of vulnerabilities. Data Protection API provides transparent encryption. Identity and authorization frameworks handle complex scenarios natively. Secure defaults, HTTPS redirection, HSTS, anti-forgery tokens on by default. This transforms security from reactive to proactive. Developers can leverage these primitives without deep security expertise. Built-in anti-forgery, request validation, and model validation prevent common attacks without developer action. Think about this for a second. .NET security architecture layers. Transport HTTPS HSTS certificate validation TLS 1.3 enforcement. Authentication JWT OAuth 2.0 OpenID Connect external providers multi-factor authorization. Policy-based, resource-based, claims transformation, role checks. Input validation, model binding, request validation, anti-XSS encoding, parameterized queries, data protection, deep API, Azure Key Vault, column-level encryption, data masking, output encoding, Razor auto-encoding, CSP X content type options, secure communications with TLS, WCF replacements. Each layer addresses specific OWASP categories. Middleware pipeline allows declarative security configuration. And this is where things get complex. Zero trust identity for .NET. ASP.NET Core Identity, User Store Password Hashing, PBKDF2 Argon 2, 2FA, Account Lockout. External Authentication, Azure AD, Microsoft, Google. Social Logins 1 Add Convocation Call. Authorization policies, require manager role, can edit order expressed in code. Resource-based authorization, authorize against specific entities, not just roles. Claims-based, flexible, fine-grained permissions via claims transformation. Token validation, lifetime issuer audience checks built in. Integration with Azure AD B2C, Identity Server OpenEdict. Supports Microservices Federation and API Gateway authorization. External claims transformation enriches tokens for downstream services. But here's where it gets interesting. The secure.NET development pipeline. Scaffold, .NET new WebAPI auth generates HTTPS identity secure defaults. IDE, Roslyn security analyzers flag SQL injection, hard-coded secrets missing validation. Pre-commit, Git hook scan for secrets, sensitive files. CI, SASQL, SemGrep, dependency scanning, .NET list package vulnerable. Container, base image scanning, non-root user, read-only file system. CD, DAST, policy gates, immutable signed artifacts. Monitoring, runtime security, app insights, anomaly detection. Feedback loop, vulnerabilities fixed in sprint, not post-release. So what's the real problem? Let's talk about policy-driven security. Policy as code, Azure Policy, OP, custom rules for .NET configuration. Infrastructure as code, Bicep templates with secure defaults, DATTPS managed identity. Secrets management, Azure Key Vault, .NET Secret Manager for development, no config files. Continuous compliance, pipeline gates enforce encryption, auth settings, network rules. Drift detection, automated scanning alerts on configuration changes. Automated remediation, logic apps, Azure functions revert non-compliant resources. Shift governance left, compliance embedded in deployment pipelines. GitHub advanced security integration surfaces vulnerabilities directly in pull requests. This raises a critical question from reactive to resilient. 70% reduction in critical vulnerabilities within 6 months. Mean time to remediate drops from 68 days to under 48 hours. Security debt backlog halved each quarter. Audit readiness. Compliance reports generated automatically from pipeline metadata. Developer experience improves. Security becomes a feature flag, not a roadblock. Cost avoidance. 1M saved annually per application suite. Teams adopting this architecture report 0 critical incidents post-launch. Zero-day resilience architecture limits blast radius through isolation and least privilege. Security Champions program accelerates adoption, knowledge sharing. Now, let's zoom in on autonomous application security. AI-driven threat modeling at design time suggest controls based on architecture diagrams. Runtime anomaly detection using .NET native AOT and telemetry. Self-healing microservices automatically rotate credentials, block suspicious IPs. Predictive vulnerability scoring. ML models flag risky code patterns before commit. Integration with confidential computing. Enclaves for sensitive workloads. Future .NET security evolves from framework to autonomous guardian. Ecosystem, NuGet package provenance, signed assemblies, software bill of materials SBOM mandatory. Quantum-resistant algorithms on the horizon. .NET preparing for post-quantum cryptography. Community-driven security analyzers enhanced with GPT models provide real-time guidance.